Question number 1. An astronomical telescope is in normal adjustment. If the focal length of objective lens is 80 centimeters and the angular magnification is 20, what is the distance between objective lens and eyepiece lens? We know that for the normal adjustment of astronomical telescope, sum of focal lengths of two lenses should be equal to gap between two lenses, because of object is at infinity. The first image is formed at focal point of first lens. It means objective lens, F4, focal length of objective lens. And second image, last image should be formed at infinity. To bring this object to the infinity as an image, this distance should be focal length of eyepiece lens. And we know that magnification, angular magnification of lens, angular magnification of astronomical telescope should be equal to F4 over Fe for the normal adjustment. Focal length of objective lens divided by focal length of eyepiece lens. Now they have given magnification 20 and objective lens, focal length of objective lens 80. Then we can find Fe. Fe is 4 centimeters. Then this distance is 4 centimeters. This distance is 80 centimeters. Then gap between two lenses should be 84 centimeters. We can obtain third one is the correct answer. The second question is the 25th question of 2024 paper. Two thin glass lenses in contact has combined power of plus 3 diopters. If one lens is convex and has focal length 20 centimeters, what is the type of focal length of other lens? Type and focal length. We can use equation for the lens combination. 1 over F equals 1 over F1 plus 1 over F2. Sorry. 1 over F is the power of lens combination. It is plus 3 diopters. We can get first lens is convex lens. For the convex lens, power should be a plus value, and it is 1 over focal length. 1 over 20 centimeters, we have to convert centimeters to meters, therefore we have to put 100 to the opposite side. Plus 1 over F2. Then we can cancel out 20 and 100, 5. Then we can bring 5 to the left hand side. 3 minus 5 is 1 over F2 minus 2. It is lens power. Lens power is a minus value. It means it is a concave lens. And we can find F value. F is 1 over 2. 1 over 2 meters. It means half meters. It is equal to 50 centimeters. Then focal length is 50 centimeters and it is concave. In the third question, it is 37th question in 2024 paper. The bottom of a rectangular isosceles glass prism is just touching a liquid surface as shown in the figure. A monochromatic ray of light parallel to the liquid surface enters the prism and passes along the glass and liquid interface. What is the refractive index of liquid? We can consider the given diagram. This side is touching with liquid and initial ray is parallel to this side. It means this angle should be 45 degrees. And they have marked the refracted angle. This angle is 30 degrees. Then we can use Snell's law for this point. We can write refractive index 1 into sine 45. It is for this medium. It should be equals to refractive index n of the prism material into sine 30. Then we know that sine 45 is 1 over root 2 equals to n times sine 30 is half. We can cancel out root 2 and we can obtain n value is root 2. It is refractive index of prism material. Then we can consider refraction of this point. This angle 30, this one 90. It means this total angle 120. This one is 45. 125 plus 45, 165. This angle should be 50. And therefore, this angle should be 70, 75. Because of this one is, this total angle is 90 degrees. Then we can use Snell's law for this point. Refractive index root 2 into sine 75 should be equals to refractive index of this liquid n dash multiplied by sine 90. We know that sine 90 value is 1, then n dash is equal to root 2 sine 75. Then we can obtain second one is the correct answer. Then question number 4, it is 48th question of the 2024 LL paper. An observer can see the top of a thin plastic strip attached to the wall of a beaker when the eye is at a position as shown in the figure. The length of the strip is h, the diameter of the beaker is 2h and the height of the beaker is 3h. The beaker is then filled with the transparent liquid up to a height of 2h. Now the observer can see the bottom of the strip without change in the position of eye. What is the refractive index of liquid? We can consider given diagram. This one is the ray coming from this plastic strip, and I should be placed at this point. After filling corresponding liquid up to a 2h height, this one should be h because of full height is 3h, then filled height is 2h. And we know that when considering this large triangle, this side is 2h and this side also 2h because of diameter of the container is 2h. Then this angle should be 45 degrees. It is equal to the incident angle for the ray after filling the corresponding liquid. It is 45 because of now the ray will pass in this way. And we can consider this angle as the refracted angle. If a ray is passing, moving from this side, it will move along this path. Then we can get this angle is 45, therefore if this height is h, this height also should be h. It is an isosceles right angle triangle, this one is. Then we can use this distance is h, this height is 2h. We can use Snell's law for the ray passing through the liquid. 1 into sine 45 should be equals to refractive index of corresponding liquid into sine r. Then sine 45 is 1 over root 2 n into sine r. We can get sine r opposite of this angle h. Hypotenuse is this side. We can write it by using Pythagoras theorem. Then h divided by this side is h squared plus 2h squared root. Then 1 over root 2 equals to n times h divided by h squared plus 2 squared 4h squared. It is 5h squared. We'll get in root 5 times h. We can cancel out h and h. Then we can subject in. It is root 5 over 2. Then we can obtain second one is the correct answer for fourth question.